Hello, my name is Marge Benham-Hutchins, and this presentation will be on database concepts. For the purpose of this discussion, we're going to look at data from the point of view as it being an input into the computer. The computer itself is a process, and the output is information. So basically, a computer program turns raw data into meaningful information, and it is a building block for the formation of knowledge. So we are going to concentrate on electronic databases. Sometimes it's helpful to think of them as files or filing cabinets. That's where a lot of the language we use when we're talking about electronic data comes from, is this traditional filing system, except that we now have a variety of ways to store that data in an electronic way. An important concept is that of a database. This is a repository of integrated records. And you can see this definition here that calls it a collection of data organized in software that can be accessed, managed, and updated like an electronic file system. This is important to think about because if you're collecting data or you need existing data, you have to know how is it collected, where is it stored. And that would mean that you would need to know more about the database. So some components of a health database would be patient demographics. So if you're doing a study of some sort and you're going to have certain patients, even if it's de-identified, you need to know what demographics are they collecting. So what is available? What demographics do you need to collect? And then, of course, in healthcare, there's a lot of information around patient billing, accounts information, financial data. And then what most people would think of as probably the most important, and that's the patient treatment and progress notes, the clinical data. And that needs to be kept in a database also. So database management systems are important to understand. These are software that are used to enter, organize, or reorganize, and retrieve, manipulate data from one or more database. This could be Oracle, Access, SQL, within certain statistical programs such as SPSS. Some people will even use an Excel sheet as their very basic database. Another place that some people will have their data and will store it will actually be in a survey software, and they will be able to download from there into a statistical program. So in some instances, data is retrieved using what's called query language. And so this is where you may have a Oracle database or a SQL database, and you develop a code that you're asking the database to provide a particular type of medication. So in this particular case, this is a very basic, what medications were prescribed for Mrs. Jones on Friday, and you get some information back, and that's querying the database management system. The databases need to be very carefully designed, and there's a whole specialty area on database architecture, and there are many different models. The one we are going to talk about a little bit more here is what they call relational databases. So it's important to understand the anatomy of a relational database. It is made up of tables, and the tables are made up of fields and records. A field is what they would say would be an atomic level, the smallest possible entity that has meaning, and the data represents the same characteristic for each record, and it's usually a vertical column. A record contains all the data relating to a particular entity. It's made up of fields, and it is in a horizontal row. A table is made up of fields and records, and this structures the data by fields and records, allows the manipulation of the data. So here's an example of a table. You could see the fields are labeled and the records are labeled. So the fields in this particular case would be the first name, last name, city, state, gender, the height in inches, and the weight in pounds. So if you look at this quickly, and as a healthcare provider, you might think, oh, I could figure out BMI using this. And so you could query by the city, gender, calculate the BMI, and identify individuals outside particular parameters. That might be something that you could do. And the thing about queries is that the data in the underlying table is not changed, but the records are sorted and used for calculations and retrieve using queries. So this is where you may sometimes hear people say, enter once, use multiple times. These are some very basic examples of data manipulation that you can do when you're doing a query. You can sort, you could do some Boolean arithmetic, true, false, so you want just male or just female, and or not. So maybe you want all females that live in a certain city that are above a certain weight. And then wildcard, that would be an asterisk, and you could do greater than or less than. You could have calculated queries that are date arithmetic, or they could be calculated based on existing data. For instance, your BMI that we mentioned a minute ago, or pulse pressure and things that are used and calculated based on existing data. So there are some common database field types. You're probably familiar with these just because when we fill out online forms and things like that, there are certain things that sometimes they won't let you put in a particular box, or they're limited. And so these are formatted fields for a database that's taking your information. So in the case of a text or alphanumeric, these can't be calculated. So one of these might be something like a phone number, or this could be a street address. This could be somebody's name. You know, these are not things that you can actually use a mathematical calculation on. Numeric, that would be fields that could be calculated, and that wouldn't be a phone number or a social security number. Those are not. Those would be considered text alphanumeric. Time date, this may be part of a calculation, but would be in a predetermined structure so that it could be analyzed or it could be calculated. A memo could be a text field. Lookup, that could be a field with a specific list of data, Dropbox. So you may run into this sometimes when you're looking for a state. It may show a state and you select your state. So that's something that they already have determined what will go in that box. You select what applies. Auto number, this quite often is something that could be done in the background, and this could assign a number to a particular record, and that is a way for you to keep track of the data for a particular record. And then there's object linking and embedding, and that's things that are linking to graphics and that type of thing that can be part of databases. So a data warehouse is a collection of many interoperable databases. So in this particular case, you could see that this is the Colon Cancer Care in Alberta, Canada. And they have a data warehouse, and that has things such as the cancer registry data, electronic medical record data, long-term care, home care, census data, outpatient data. So all of these things are kept together in a data warehouse. So it's many interoperable databases. In order for this to work correctly, there's got to be some standardization of the field types and the variables, and that's an important component of getting things to work together. So I like this particular diagram because it shows the National Institutes of Health and their data repository and data warehouse architecture. And so you can see here the clinical data repository information comes into that repository from a lot of different sources. It could come from surgery, consents, document management, home monitoring, medical records, any number of things. And these all come into this clinical data repository. This information is then put into the data warehouse, and then it can come back out of there to be used for a variety of other things, such as decision support, resource utilization. They could use this data to determine that, let's say in surgery, we used a certain amount of materials and we need to reorder. Pharmacy, same thing. It could be keep track of what medications are being used, but also it could be in the background helping the pharmacy determine what they have to order. So there's a lot of different ways that this could be used. And at the NIH, they have care for patients there. They have a main hospital, and they want to be able to use the data collected on caring for those patients or on various clinical trials. They want to be able to reuse that data later for ongoing research. So they've developed a very viable infrastructure to be able to do that. So data mining is an important thing to be aware of when we're talking about clinical data, because we're going to look for hidden patterns and relationships in these large groups of data. This could be performance information, successful treatments for specific diseases, a lot of knowledge discovery, looking for patterns and trends. You could sort and compare the data in many different ways. So for quality improvement, you maybe look at the data that you've got available and look for patterns and relationships. Infection control. This is something where you can narrow down to, we had an infection in this particular room, this particular patient, what patients were previously in that room, what providers have been in and out, what types of auxiliary staff have been in here. Have we had people that have even worked on the AC system, for instance? There's a variety of different ways that you can narrow down if you're able to interconnect these data and it's interoperable and you have a way to mine the data. I really am very fond of this quote because some people say, well, what have electronic health records done for us? But if you think back to paper records, or if you ever worked with them, or if you just think about what they actually are when you take a note or do something like that, they just wait there for something to be done with them. They're not anything that you can use to manipulate the data, to pull out information. Data mining, chart review used to be a manual process where you literally went through and you reviewed the paper charts and you had to find certain information. Now chart review can be done through data mining of the electronic health record, and it really makes a huge difference. And so we actually have this valuable data that we can reuse to make decisions and clinical surveillance activities. So there are a variety of ways to do electronic clinical surveillance. The most basic is an algorithm that is created by experts, and this is depicted as a flow chart. So in other words, if this happens, then you do this. And so consequently, they are more static, but they also help you to identify trends. You can monitor the contents, generate warnings, and even make suggestions such as decision support. A warning that you may think of is you have information on a patient allergy and you just prescribed a medication that may be contraindicated, or there may be a drug-drug interaction or something of that nature. And sometimes decision support can be built into that will give suggestions to a provider based on the information that's in the data. So this could be, we do things to monitor skin breakdown. So there may be an alert to say a patient has high risk of skin breakdown or falls, and then that is something that is going to help the provider make some determinations. It also can automate quality control. The surveillance will actually, help pick up possible errors. And then it could be feedback, deviations from standards, which could include data entry. This is when you try to enter something and it won't let you. Well, it's because it can't read that, and it's going to make you enter it in a certain way so that it can be read. And the same could be you're entering the wrong information in a particular field, that it will recognize that and give you feedback. So this is an example of a algorithm. So in this particular case, it's a scoring system at risk of their condition deteriorating. So in the background, this particular computer program may make determinations and give you warnings based on scores or responses to certain information. In a more sophisticated form that we now have, we call it machine learning, where the machine actually itself, through what people program into it, can then start picking up patterns and identifying patterns based on the information. And that's a lot more complex, and artificial intelligence is very similar. They're fascinating and really, I think, the future. So here are a couple more examples of the types of automated clinical surveillance systems that you may run into. So here you see some built-in algorithms that could be, they're developed by healthcare providers, so they should be evidence-based. And they examine the electronic patient data and it looks through the data, and then it performs an early warning system. This could be septic shock, fall, skin breakdown. It might ID patients based on individual characteristics and send a notification to the nurse, pharmacist, or physician at the point of care. So for instance, certain parameters change and it appears that this patient is more at risk of skin breakdown or fall. It will send a notification to reassess the patient. Perhaps they just came back from surgery, and so they're more at risk of skin breakdown and falls. And so that's something that is important for nurses to know. So I'm going to wrap up this little discussion now. This is a very basic overview of databases, and it's something to get you started. So if you're thinking of doing a quality improvement project, most DNP projects are going to be on a quality improvement level. Think about the data you need. What is the theoretical or de-identified nursing scenario that incorporates data warehousing and data mining for outcome in our quality improvement reporting? For instance, you want to improve the fall rates. Where would you get that information? How would you know the current rates? How would you know what was being done? Where would you find this? Identify the levels and the type of the data that are required. These are very important things to think about as you're designing your project.